So, in addition to what we have done in our previous class, we require some more models to go through. I think all these models I have covered actually, the initial stages, all these models. There are three famous models which are on the basis of this particular theory concept. Remember, whenever such a model arrives, I told you number of times. I told you in this particular models, you need to identify first what is the direction of E bar. I am repeating again, E bar. E bar, it can be even weight component also. The next thing you need to identify E bar cross B bar direction. And if a charged particle is released here, it will follow a cycloid path like this. A cycloid path like this. This is the cycloid path. In this, I told you very clear, if you are taking this as E cap as some X and this one as some Z, for example. So I have given you very clearly the expressions for velocities and positions along this direction. They are nothing but you just remember V. If you remember V, you will get everything. The V term in this case is E by B sin omega t. And Vz term is nothing but E by B 1 minus cos omega t. Similarly, X term is E by B omega 1 minus cos omega t. Similarly, Z term is E by B omega t minus sin omega t. Remember, I just retrieved all from velocity expressions only. These things, cycloid problem is a cakewalk for you. Okay. This I have derived actually in the class. But still, I'm just revising this because I am going to use these models, this particular concept today to solve my questions. Now we will go with the first question. Hold on. Most of these questions I have done. All these I have done. All these. Hold on. Today the questions which I am dealing are really, really very important. Ultimate care must be taken to digest these things. This is the question which I would like to discuss. And I think there is a fresh entry for me. Let me work on there. Let me work on there. This is the question. And followed by there is one more question related to the same. But first let me handle this question. Before this, I require one more question also. I'm searching for that. Probably I would have thought you otherwise. And no issues. I'll just introduce that question to you right now. Very good question, actually. Oh, I got it. I'm sure you are going to get this question anytime in the current weeks. Right. Done the pasting part. A particle having charge q and mass m is dropped from a large height. Now, please try to understand here very clearly. This is E bar direction. Of course, don't mind, this is nothing but right. And B bar is into the plane of the board, which means E bar cross B bar, E bar cross B bar direction will be in this direction. E bar cross B bar direction is in this direction. Very simple. If you take downward as minus j cap into the plane as minus k cap, minus j cap minus k cap, j cap cross k cap is I cap. So minus j cap cross minus k cap is plus I cap. That is how I have identified. And I told you, if you release a charge here, that will act as if like some decorative arch for E bar cross B bar axis. Yes. Now this will become your X part. This will become your X part, which will be E by B times sin omega t, velocity component. Whereas in this direction, just now I have derived all these things. In this direction, the component of velocity will be E by B times 1 minus cos omega. Right. Argue qualitatively that the particle will touch the maximum depth. You want this distance, maximum distance. Very simple. You want maximum x coordinate. Now, x in the sense e cap component, e cap coordinate. The e cap position coordinate is going to be E by B omega into 1 minus cos omega t. What is going to be the maximum value of this term? The maximum value of this term is going to be 2E by B omega. So therefore, if this is a H max is going to be 2E by B omega. Now we will do every transaction properly. What is omega? You already know. Omega is BQ by M. What is E? Mg by Q. So finally, what is that you are going to have is 2 times M square G by B square Q square is the maximum depth that you could expect this particle to come down. Hope I think is it possible for you to communicate with me? You say yes or no, any one student at least. If not, leave it. Find the speed of the particle at the moment it starts climbing up. Climbing up is happening at this point. You want the maximum velocity. So what is the maximum value of this function? 2e by b. There is no e term. Don't forget that. This is nothing but 2mg by pq. So I have done A, I have done B. At what depth from the starting point does the particle starts climbing up? Done C. So in see how simple the solution is of this particular one. You can see that how simple is the solution. I told you very clearly simple concepts you need to identify. Point number 1, identify the direction of E. You name it some whatever you want. E bar cross B bar, you name it some whatever you want. Then accordingly, the component position coordinate along E is E by B, 1 by E by B sin, velocity is E by B sin omega t. Position coordinate is E by B omega 1 minus cos omega t. Please try to understand. This is a very simple logic. If you remember this, you are done. And one more important point, I'll add one more important point to this. If a particle is going in a cycloid path, first of all, where did you learn the cycloid path first time? Imagine this is a ring, and the ring is under combined rotation and translational motion on this floor. Now you take a point A here. Now this point A this point A, while the ring rolls, this point A will follow a path like this. This is called cycloid path. Now, which means at the point when it reaches the maximum height point is 2r. And the length of this entire path is 8r. 8, A1, A2. So length of the path A1, A2 will be 8r. Please remember that. This is the fundamentals of cycloid path. Every particle follows the same path. It is like this path is called cycloid path. Cycloid path. Now, on the basis of which we have a question. Right. This is the question. A rigid ring is made to roll along the ceiling of a room where a horizontal, uniform, and static magnetic field of induction B exists perpendicular to the plane of the ring. Here it is into the plane of the ring. Right. The velocity of the center of the ring is a constant and its modulus is V. Charged particle P of mass M is fixed to the ring. Charged particle P of mass M is fixed on the ring. What should be the charge Q on the particle and radius R of the ring be so that there is no force of interaction between the ring and the particle? It is possible if the charge follows a cycloid path. If the charge is following a cycloid path, there is no interaction between the ring and the particle. Because even if you leave a charge at origin, it follows the same path. So whether the ring rolls or not, whether the ring rolls or not, mud, if it sticks, it will leave at some point. But here it won't leave at that point. Continuously keep moving in the same cycloid path. In other words, if a point on the rim of the ring follows cycloid path, undoubtedly, if the charge always follows the same cycloid path, then there is no interreaction between the ring and the charge. Fine, everything is fine now. Now, what is your problem? Remember, this is E bar direction. This will be our traditional X. Fine. This is our traditional Z. Fine. No issues. Now, in the place of E, we have mg by q. Fine. In the obviously, when this is E bar direction and when this is inward field, just now we have seen this will be the direction of E bar cross a B bar. What do you want? What should be the charge? Right. What should be the charge on the particle and radius r of the ring be so that there is no force of interaction between the ring and the particle? Simple. If the depth which we have measured earlier is equal to 2r. What is 2r? 2r just now we have done. 2r is nothing but 2e by b. Just now we have done. 2r is 2e by b omega. R is mg by b omega we have done. E means mg by q. So R, if satisfies this condition, then this is possible. Similarly, V. Suppose if the center is having V, this particular point will have a velocity 2v. That is a maximum. And that 2v, if it is our 2e by b, that 2v is our 2e by b. Don't forget the same question we are discussing here. Just discussed the same question here. You can see that. Just see that. This 2e by b is the maximum velocity. Same 2e by b, if exists here, 2e by b. So v is mg by bq. If q satisfies this condition or satisfies this condition, it is possible. So I taught you two questions on the same. Remember, two questions, not even one, two questions. Next, some more models. I covered all. 1 minute. One after the other I'll cover. There are few models. This one also same model. Actually, I'll cover one by one. Just give me time. Yes. This is a very standard question and which you are expected to repeatedly. This model will repeatedly be questioned. Even now, in grand tests also, what do you call, these questions are given regularly. Our seniors are writing this. What is the question here? A particle of charge Q, mass M, moving under the influence of a uniform electric field. See, where is electric field? EI cap. Electric field is in the horizontal direction and uniform magnetic field. Magnetic field is outwards, right? Figure shows the trajectory from P to Q. Yeah, shown in the figure. And also the velocities at P and Q are also mentioned. One is VI cap, the other is minus 2V J cap, means 2V downwards. And this distance is A and this distance is 2A. This is clearly given in the diagram. Which of the following statement is or correct? Right. My point is very clear. My point is very clear. Here, electric field does work. And it is a uniform electric field. So it does a constant work. What is the work done by the electric field? QE times force into displacement. QE and displacement in this direction is 2a. What is the expression for work energy theorem? Work done is change in kinetic energy. 2QEA is half m 4v square minus v square, which means 2QEA is 3 by 2 mv square. E accordingly is 3 by 4 mv square by QA. This is first option and correct. And they are also asking the power rate of work done by the electric field at P. Power is nothing but dot product of force and velocity vector. At this point, QE is the force, V is the velocity. So use that E here. You will get 3 by 4 mv cube by A. Now, see, when B is correct, C is wrong. Rate of doing work by the fields at Q is 0. Hold on. Magnetic field never delivers power because always force of magnetic field and velocity are always perpendicular. So it won't deliver any power. First point is out of our box. Next point, here at this point, the electric field is in this direction and the velocity, instantaneous velocity is in this direction. Again, they are mutually perpendicular. So no power. At that instant, no power. P is V E F bar dot V bar. Dot product is 0 at that point. Right. Next. That is one model which you need to know. This is also a very important model. It is better I do this, but no space here. That's the problem which I'm facing. These two are very important models. How? మన హోంవర్క్ దీనిలో ఉన్నాయా అవి ఒక్క నిమిషం లెట్ మీ జస్ట్ సీ because 1 minute please. As I know that I have given these questions in homework also. If it is not available, then it's not in the homework part. Chalo, no issues. I will try to copy this smartly. Copy. Okay. 1 minute. We will a very important model. Same comes under the same track. Okay, hope you can see this question clearly. Proton of mass m and charge q is released from rest from the top of a building of height h in the presence of a uniform gravitational and magnetic field. I don't see any difference between this question and the one previously which I have done, which means now I have clearly understood that this is E axis. E is nothing but mg by q, right? And we have E bar in the direction downwards, okay, and inward magnetic field. So therefore, obviously, this is going to be the direction of E bar cross P bar. Remember, once I am identifying this, I can conclude what could be the situation for someone which was released. This is how the path is expected to be cycloid path. And remember, as usual, this is the floor and this is height h, right? Okay, no issues. Distance traveled by the particle from, no, 1 minute. Ground for the first time at C. C, right. Hold on. Just hold on. Distance traveled by the particle from A to C. Okay, no issues. First, write the coordinates. Write the coordinates. Now, in the direction of E, just now we have done all these things. So, x coordinate, this is our formerly x, this is formerly our z. What are x coordinates? Our velocity in this direction. This is E by B sine omega t, velocity, Vx. And x is E by B omega 1 minus cos omega t. And Vy is Vz is nothing but E by B 1 minus cos omega t. E by B 1 minus cos omega t. Now try to please understand, try to link that. You are released at A from the top point of the building of height h in the presence of a uniform gravitational field and magnetic field, and it is touching the floor. What is h according to you? H according to me is x max, which is nothing but 2E by B omega, which is nothing but 2 by B cube by M. In the place of E, you have mg by q. So finally, H is nothing but 2 times m square g by b square q square. That is H. What is the velocity of the particle at C? Okay, Vz max. Vz max. This is nothing but 2E by B, which is nothing but 2 times mg by bq. So I have given you Vz max, maximum speed at C and H. Now distance traveled by the particle from A to C is 2h. How do I know it is 2h? Hold on. We already know in a cycloid path, I just told you, in a cycloid path, this is the cycloid path. Cycloid path. In cycloid path, if suppose this is A, this is a C, and say this is A dash, you know this is a 2R. And AC A dash is equal to 8R, which is nothing but 4 times H. If you want only AC, half of AC A dash, which is nothing but 2h. So therefore, distance traveled by the particle from the A to C is 2h, correct. Horizontal separation between the 2 points A and C. You want this distance. Fine. That distance is nothing but, hold on, I'll give you that distance also. From here to here, it will simply travel a distance of 2 pi r. 2 pi r. Or if you are not convinced, you have z coordinate also. What is z coordinate? E by, in terms of h only, I think they are asking everything. No issues. In terms of h only. In a cycloid path, this particular distance will be 2 pi r. Distance traveled by the center of the ring, 2 pi r. Or you just concluded, no, where r is h by 2. R is h by 2. You want only horizontal distance. And this will be pi r. Just now you have concluded h is nothing but 2r. So therefore, in the place of this, you should write pi into h by 2. So since horizontal separation between A and C is given as 2h, wrong. It should be pi h by 2. So B is wrong. Velocity of the particle at C. Right. This we will find. Just please let me write this properly. Let that be VC. VC is 2 mg by BQ. If you allow, I will write this as 1 minute. M square G square B square Q square. I'll write like this, and I'll put a root mark here. If this is the case, from this you can remake it as mg by bq can be given as h by 2g under root. So therefore, mg by bq square is nothing but 2 times m square g square by b square q square can be given. I think at both the sides, I think g. 1 minute, small mistake. mg, both the sides gh by 2 whole power 1 by 2. Just multiplied both the sides g here, right? mg by bq is gh by 2 power 1 by 2. You want mg by bq here, 2 mg by bq. That's what you want. So 2 mg by bq is nothing but under root 2 times gh by 2 under root. This is nothing but root 2 gh. Right. Otherwise also you can write it simply as root 2 gh because work is done only by gravity. So therefore, any object which is released from h undoubtedly attains root 2 gh speed. Time of flight of the particle from A to C. The time of flight, total time is 2 pi m by bq. From A to C, C to A dash. But you want only from A to C, which is half the time period. This is pi m by bq. So this is wrong. Now please go through the entire question one more time. You are expected to have this question. See, all this is on the knowledge of the cycloid path. If this is the cycloid path, the horizontal distance of cycloid path is 2 pi r, and the length of this path is 8 r, and the height of this path is 2 r. This is the geometry of cycloid. And this is one full time period, 2 pi by omega. This is one full time period, 2 pi by omega. This is the basic understanding of cycloid path. If we know this, you can manage that particular question. Okay? Hope this part is clear for you. Done. Yes. To take this part, the figure shows a coil bent with all the edges of length 2 meters and carrying a current of 2 amps. There exists in space a uniform magnetic field of 2 Tesla in a positive y direction. Find the torque on the loop. Please conclude the magnetic moment part. On the basis of the bending, I can see 3 phases here. On the basis of the bending, you can see the first part here is going to be this one. That is the first one, whose magnetic moment M1 bar is in this direction. The second part is going to be in this direction, which is going to be in this direction. I am just using right hand grip rule. Same thing for 3. And for 3, you can see that the magnetic moment vector, it is directed downwards. Frankly speaking, 1 and 3 mutually cancels each other because they are exactly same in magnitude but opposite in direction. The only thing that contributes the magnetic moment part is this loop alone. And that loop's magnetic moment is along J cap. So M1 bar, M2 bar, M3 bar. M net is 8 J cap. Right. What is the direction of B bar? B bar is also along J cap direction. It's given in the question C. B bar is also in the J cap direction. So magnetic moment along J cap direction, B bar along J bar direction. So the cross product is 0. For such an arrangement, the torque is 0. This I have done. This also we have done. This also we have done. This part also done. Now we will work on this. Both questions are same actually. This one as well as this one. This is also given in H.C. Verma. Okay. Now go through the question now. Electrons in a beam are accelerated from rest through a potential difference delta V. The beam enters an experimental chamber through a small hole. Here you can see the whole part. As shown in the figure, the electron velocity vector lies within a narrow cone. అంటే వచ్చేవన్నీ స్ట్రైట్ లో రావు బట్ ఆల్మోస్ట్ స్ట్రైటే ఇలా ఇలా రావచ్చు. యూ ఇమాజిన్ ఎ కోన్. సో ఆ సర్ఫేస్ మించి ఎంటర్ అవుతున్నాయి అనుకోండి మీరు డిఫరెంట్ డైరెక్షన్స్ అలా. బట్ వెరీ స్మాల్ యాంగిల్ అండి, గుర్తుపెట్టుకోండి. ఇట్స్ వెరీ స్మాల్ యాంగిల్. We wish to use a uniform magnetic field directed parallel to the axis of the focus to the beam so that all of the electrons can pass through a small exit portion on the opposite side of the chamber after traveling a length d of the chamber. What is the required magnitude of the field? In this situation, the electron follows a helix path like this. See, for example, it is entering like this. Here, one full rotation is completed, for example. Okay? And this distance is called one pitch. One pitch. If D could be one pitch, see, all that which are entering, say, in this direction, will come out almost in the same direction. Anything, for example, if an electron entered like this, it comes out like this. Initial direction and final direction are parallel. For example, if an electron enters like this, it comes out like this. So therefore, minimum length of this must be one pitch. Pitch is V cos, already we know this, V cos phi into T into time period. So therefore, V cos phi 2 pi m by BQ is D. By the way, what is V? How you got V? So kinetic energy, this part, work done by, there is a potential difference, no? Here there is some potential difference V, and that has done some work. because of which there is gain in Ke. So that part I have taken. Now I got V as a function of potential difference. Now V cos pi 2 pi m by BQ is D. You want B basically, and I am giving you the B from these observations. I am telling you this is a gunshot question for you in upcoming days, whether it is a VAT exam or next week VAT exam or any cumulative exam hereafter. It's a gunshot question. Right. Do not compromise in this. And this is fine. Already we have done this part. This question is same as the above one, which we have done. Let me just confirm whether anything else left earlier. I think I have covered all. No, there is nothing pending in this side. This side, there is no pending. No pending part. Yes, I have done all. Done all. I have done all. Right. Now we'll go far away from here. Literally, we'll go far away from here. All this we have done. 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 Oh, this one also we have done. Practically, we have done. But still, let us try to do this question again. Please read this question carefully. We have already done this question, but still read this question carefully. Everyone, try to read this question carefully. I told you today we will discuss strictly difficult questions. I'll come afternoon if possible, and I'll try to check homeworks. Right. Let us be back to this question. Charged particle of mass m and charge q is projected on a rough horizontal xy plane. Z is vertically upwards. Both Z is projected upwards. Right. Now the question is, earlier, this one also I want to do separately because this is all crowded. When I'm doing such adventures, just it will take some time. ఇప్పుడు సేమ్ క్వశ్చన్ అక్కడే డిస్కస్ చేశాను అనుకోండి, మీకేం అర్థం కాదు. రైట్. Right. Now we have everything available here. Now please go through the question. Charged particle of mass m and charge q is projected on a rough horizontal xy plane. Z is vertically upwards. Right. Z is vertically upwards. Right. This is Z. Obviously, this one should be X and this one should be Y. Because I cap cross J cap is K cap. Right. Both electric and magnetic fields are acting in the region. E bar is equal to, you have electric field, magnetic field in both the same directions. Frankly speaking, both are into the plane of the board. Particles enters into the field at a naught comma 0 comma 0 with a velocity, which means it is entering somewhere over here. And that too with a velocity given by V naught Z cap. And this is at a distance A naught. Right. The particle starts moving into a curved path on the plane. Remember, curved path. Why so? Suppose if there is no magnetic field. Suppose if there is no magnetic field, what would have happened? In the case of no magnetic field, there is electric field. The electric field, this is a positive charge, by the way. So the electric field would have exerted a force in the direction of the field for a positive charge. In that case, what would have happened? The force is such that it exerts additional normal reaction force apart from the weight. In fact, the force on that will be more than mg. Okay, right, understood. Now, what is the normal reaction at this point of time? I'll use the space properly so that maximum question is visible. So please try to understand what is normal reaction here. Weight which acts in the minus k cap direction plus EQ naught, which also acts in the negative z direction. This is the very first observation. Whether there is a P or not, this is true. Now, what is going to happen? The particle starts moving into a curved path. Okay, our coefficient of friction is also there, right? No issues. At some instant of time, at some instant of time t, it may have some velocity. That instant minus m dv by dt is an acceleration. This is equal to, by the way, I just have a doubt. What is going to be the direction of magnetic field? What is the direction of the force of magnetic field? V bar cross B bar direction, which lies in the plane XY only, right? Now, what is going to be m dv by dt? And this is going to be mu n. This is going to be dv by dt, and which is equal to mu times mg plus eq naught, because you know magnetic field do not affect the speed. That is the reason why there is no magnetic field term in this point of view, right? So we'll take this as equation 1, equation 2 actually. 1 we have already used for normal reaction. Now I'll change the color of the pen. Now this can further be written as minus m dv is mu mg plus eq naught dt. Now do the integration properly. You said at some time 0 it entered with speed v naught. At some time t it is coming to rest. So this is mv naught is mu mg plus eq naught tick. So finally I got the t part. The time taken part will be mv naught by mu mg plus eq naught. Boys and girls, this is the first observation. I am repeating again. I didn't use any B bar term here because B bar term will affect only in the direction change. So I am writing here magnitude of the change of the speed. For that, you don't require that term. So time when the particle will come to rest is mv naught by mu times mg plus eq, which is not here. So this is wrong. Time taken by the particle will reach the initial center of curvature is right. That is okay, fine. Now we got the time part, right? Next part, the distance part. Distance part we will work. How the way you have written this equation, you can rewrite this in another form, minus mv. Remember, I am writing distance part. Mu mg plus eq naught. I'm writing the same thing in a different way. So minus mv dv is mu mg plus eq naught ds. Do integration on both the sides. Again, when it starts, speed is v naught. After traveling some distance, speed is 0. That's what you're asking. So finally, S can be written as mv naught square by 2 times mu into mg plus eq naught. Right. That is S part. By the way, I have done only 2 at this point of time. Still 2 more are pending. Right. Now, if I take this part, what do you call, 2 parts I have done already. Displacement of the particle when it comes to rest. Displacement of the particle when it comes to rest. What is velocity term? V bar is ds bar by dt. So integral ds bar is v bar dt. Right. Okay. Integral ds bar is v bar dt. Do we have any v term? Time taken by the particle will reach the initial center of curvature. Wrong, that is wrong actually. Displacement of the particle when it comes to rest. Displacement is what you want. Hold on. Let me write the forces now completely. At any instant, what are the different forces that it is experiencing? Mu n is the magnitude. Mu n is the magnitude, friction part. V cap direction. Direction is opposite to the instantaneous velocity. Plus Q V bar cross B bar. This is the net force. Actually, this is the net force. M dV bar by dt is minus mu n. N is a constant term. B. B is which direction? Minus B naught K cap. Hold on. M dV bar is minus mu n V cap dt plus Q into I cap cross K cap minus J cap. There is a minus here already. J cap cross K cap is I cap, but there is a minus here. Right. This is the part. Now by into dt is also there. If I do M dV bar you know what I am going to get here? Q B naught, I will get X J cap here minus P naught Vy I cap kada. This will become Q B naught Y I cap. Now remember, at an instant you are working, right? By doing this integration properly, we will get what do you want? X and Y values from this. So magnitude of X square plus Y square gives you D. Okay. Because space insufficiency is there, just work on that part. Or else I'll do it and I'll post you. That's all. It's a very good question. Remember. Really very good question. That's what I told you here. Almost I have done this. This one also I have done. This one done. These are all Pathfinder questions. Tomorrow I'll do it. Or a separate video I'll put. This is very important. Yes, this is a very important question. A straight conducting bar AB of mass M and length L is suspended horizontally by two non-conducting springs, spring constant K as shown in the figure. The bar is located in a region of uniform magnetic field of intensity B. The capacitor C is initially charged to a potential difference V. Springs are in equilibrium position with zero potential energy. Zero means not stretched at all. At time t is equal to 0, the switch S is closed. Maybe light rod, AB, but straight conducting bar AB of mass M and length L is suspended, is what mentioned. Okay, assume the time of discharge of the capacitor is much smaller than the period of, right, okay, no issues. So what is happening initially? It can be treated as a spring block system having some mass M, spring constant 2K, right? What is happening during the time of discharge? A sudden current flows, and this gives an impulse to this rod. What is the direction of magnetic field? Inwards. Apply Fleming's left hand rule. You have inward, central finger, pointing finger into the plane, central finger rightwards, thumb upwards. So you are facing an impulse in the upward direction, which can be given as force into time of action is impulse. That's the maximum. BL, this thing is maximum. But don't forget, integral IDT is nothing but the charge. What charge was discharged? CV charge is discharged. So BLCV is MV max, and you know V max, by the way. Maximum speed is this. Okay, by the way, it is SHM oscillator whose force constant is 2K mass M. So therefore, what is going to be the time period of oscillation? T is equal to 2 pi root M by 2K. 2K. Right. Here I think some 2K term is missing. Just please correct that. I'll just write this one properly in a separate page, like what I was doing earlier. Good. Right. I'll clearly explain now what is happening over here. Mass M, length L. The capacitor C is initially charged to potential V. At time t is equal to 0, switch is closed. Switch is zero potential energy means you don't require to consider the Z term, it seems. That's what they said. Neglect the effect of gravity. Right. Now, now I am treating that this is the equilibrium position of the system. And this system is equivalent to a single spring of force constant 2m and suspended mass is m. Omega of this system is root 2k by m. Equation 1. And this is the equilibrium position. Suddenly what is happening is this rod, because all of a sudden a very small amount, a very large amount of current pass through the rod in a small interval of time. So this causes an impulse because you have an inward magnetic field. Impulse upwards, J. And that J is PIL force TT. Simply you can write this as integral B L times IDT. IDT is the charge, PLCV. So this MV max is BLCV. So V max is PLCV by M. Equation 2. So done. Wrong. The amplitude of mechanical energy of the oscillation. We know V max is nothing but omega A. BLCV by M. So amplitude of oscillation is BLCV by M by omega, which you can write it as M by 2K. Take everything inside. what you will get is P square, L square, C square, V square, of course, M by M square. Array by 2M K. That is the deal. So that is the amplitude part. B square, L square, C square, V square by 2MK. This is wrong. Right. Hope you have understood this question. Right? Okay, fine. One more question. A lot of questions were there. All these things I have done. This one also done. This one also done. Let me deal this question again. These are complex questions. Good to discuss this again and again. A charged particle of mass m and charge q is shot along a horizontal rough plane with coefficient of friction mu. Uniform magnetic field is applied at right angles to the plane. If the charged particle enters the magnetic field region perpendicular to the uniform field with velocity v0, then the radius of curvature of the path after so and so time is given by. Right. Now we want to handle this. Remember, you projected a charged particle, right? That charged particle, initially, it is in a complete what kind of field? For them, uniform angle applied at right angles to the plane. It can be inward or outward, whatever it is. I'm just taking an outward situation here. We assume that the magnetic field is outward. We have an outward magnetic field. Outward magnetic field. And you projected a charge here. You projected a charge like this with a speed v0. You know the magnetic field force will contribute only change in direction, but not in magnitude. Whereas friction will contribute change in magnitude. So therefore, minus m dv by dt is nothing but mu mg. Minus m dv is mu mg dt. Right. What do you want? At time t, velocity is v0. At some time t, let the velocity be v. So v is v0 minus mu gt. That's the fact. Now, what is the radius of curvature at any time? mv by bq. That is the radius of curvature, because this radius of curvature contributing part is strictly magnetic field. This is nothing but m by bq times v0 minus mu gt. Right. So you are asking what time? This is the time. Now, which implies R is m by bq times v0 minus mu g. Remember, you mentioned the time. v0 by 8 mu g. So finally, this is 7 mv naught by 8 dq. They are asking what is n in the denominator. The denominator term is 8. Are e question no? That's now I have discussed one question. No? ఈ క్వశ్చన్ సేమే. ఇది ఎందుకు రేడియస్ ఆఫ్ కర్వేచర్ మీద చెప్పలేదు అంటే ఇప్పుడు మీరు సబ్స్టిట్యూట్ చేసుకోవచ్చు. టైం టేకెన్ బై ద పార్టికల్ విల్ రీచ్ ద ఇనీషియల్ సెంటర్ ఆఫ్ కర్వేచర్ అంటే ఆ రిలేషన్ ఇక్కడ వేసుకోవచ్చు మీరు. రైట్. సో ఆల్మోస్ట్ మోడల్స్ విచ్ ఆర్ రిలేటెడ్ టు యూ అట్ దిస్ పాయింట్ ఆఫ్ టైమ్ ఐ హావ్ కవర్డ్. రైట్. దిస్ ఈజ్ ఆల్సో ఎ వెరీ ఫేమస్ మోడల్ which you are expected to work. Right. Wooden cubicle block can see ఇది కూడా రిపీటెడ్ గ్రాండ్ టెస్ట్ లో అడుగుతుంటారు. ABCD OEFG mass M and side A is wrapped by square wire loop of perimeter 4A అంటే 1 loop వచ్చింది మీకు. And at A/2 at A/2 as shown height A/2 ఉంటుంది అది. Right. Hold on. Now, in this question, you please try to understand. Again, Arya, just want to deal this fresh. Just want to deal this fresh. Right. Boys, this is your question. Wooden cubicle block is given for you. Right. The whole system is placed. First of all, what is the magnetic moment of this system? The arrangement has some magnetic moment. Curl your right hand grip like this. Okay. And the turn of this, I'm dealing again. Take the turn of these 4 fingers, right hand 4 fingers. My thumb is representing upwards, which clearly indicates it is along Z direction. So therefore, again say current into area is A square and the direction is in K cap. Let this be equation 1, M bar. Next, the point of application of the normal force is at a distance x from the base center. Now imagine that this is the box. This is the center. You said the normal reaction is acting at a distance x from the center. And by the way, magnetic moment vector is like this, m bar, and b bar is in this direction. So due to m tendency of rotation is like this. I repeat, due to m tendency of rotation is, in my point of view, clockwise. And one more important point is there is weight that acts in this point of view, mg. Now, what is the condition for toppling? The point here you are seeing, it should shift to here for toppling to take place. So therefore, the condition is MB must be toppling. For toppling to happen or not to happen, MB less than or equal to MGX. Okay, MB. What is MB? We have already here the data I A square B less than or equal to MGX. What is that you want? The current in the wire is I. So therefore, for avoiding toppling, I must be less than or equal to mg. Here at this point, x becomes a by 2. So therefore, I can say that avoiding toppling. So I is mg a by 2 by ba square, which is mg by 2ba. Remember, this is the maximum current that you can pass through to avoid toppling. Okay. Next. Suppose if x is equal to a by 4 in this, ia square b is equal to mg. If x is a by 4, obviously it is not toppling. But torques must be balanced, a by 4, by the way. In that case, I might be mg a by 4 times a, mg by 4ba, right? So I have done this question. I am telling you that this is a very repetitive question in our system. So don't miss such opportunities. Very, very easy and famous question. Let me try to explain you this properly. It is better that I would copy this, that do not affect the flow of my discussion. Remember, I'm in a meeting actually in a center office, Madhapur. I managed to find some time to deliver this class. Tomorrow, complete Pathfinder questions. There are 5 to 6 questions in Pathfinder which we are supposed to discuss. Now you can see here the space between the pair of a coaxial cylinders, cylindrical conductors is evacuated. Okay. What for? The radius of the inner cylinder is A, and that the outer radius is 3A. Yeah, as shown in the figure. Static homogeneous magnetic field B parallel to the cylindrical axis directed into the plane of the figure is present. An electron of mass m charge minus E starts out with an initial velocity V0 in the radial direction. The minimum value of B such that the electron does not reach out the outer cylinder is fine. Let us try to construct this again. Fine. Now, what is that you have informed me is that initial velocity V naught in the radial direction. Radial direction, right? So what is actually happening over here? You have projected it in the radial direction. Now the question is, now I need to construct another one, another circle. I mean, you see, this is the condition. Undoubtedly, you have projected it radially out. Radially out. Okay. And but the track of this, if it follows a path like this, then you are safe. For this purpose, what I am trying to do is, remember, somewhere here will be the center of the circle. And by geometry, this is, you said there are two different radius, boss, A and 3A. I should use some other term R. Why? Because this is 90 degrees. That is the center. Right. By the way, this is radius R. And this is radius A. Fine. Let us Nagendra. Uh-huh. Uh, నాగేంద్ర నాగేంద్ర నేను సెంట్రల్ ఆఫీసులో ఈ మీటింగ్ రూమ్లోనే ఉన్నా, జూమ్ క్లాస్లో ఉన్నా. ఒక 5 minutes అయిపోద్ది. వస్తావా ఇక్కడికి? ఒక్క 5 minutes. రైట్. మన మీటింగ్ హాల్లోనే 10th floor. రైట్. బాయ్స్, now you see, this is the picture I had. The minimum value of magnetic field be such that the electron does not reach the outer cylinder. Right? No issues here. Now take the geometry properly. We will use this starting point as a P, this point as a Q, and this point as O, and this point as a C. Now we will go with OC. What is OC? OC is what we want. OC. I know CQ as R. Even I know OC. How? A square plus, hold on, I got it. See, please try to understand very clearly. OC plus CQ is the distance between inner to outer, which is nothing but a 3A. Okay. 3A. Because that is a 3A. We have given, no? Inner radius of the outer cylinder is a 3A. But in this diagram, they have given B actually. Okay, no issues. We'll use the terminology of B. Finally, we will substitute the diagram. You see, they have given B from center to outer surface. So we will take OC plus CQ as B only. Nothing harm. CQ, we already know it is R. What is OC? OC is nothing but B minus R. And again, in the triangle, you see The triangle here is again 90 degrees. Here it is 90 degrees. No? OPC triangle, if you see, OC 90 degrees. This is A, this is R, this is B minus R. So Pythagoras theorem states B minus R square is A square plus R square. B square plus R square minus 2BR is A square plus R square. Right. Now cancel these two. So finally you have B square minus A square is 2BR. This is one relation which I might require. But what is R? B square minus A square by 2B. This is R of this circle. What is R? According to me is MV naught by BQ. You said the charge is E. Okay, MV naught by BQ. BE here in this case. Right. And now you substitute the place of B3A. So 9 minus 1 A square by 2 into 3A is MV naught by BE. So this allows you to write B properly as you cancel A 8 4 by 3 A. B is nothing but I got a point now. B is nothing but 3 MV naught by 4 AE. And some data is also given. Wherever MV naught is there, you can write 4 AE. So therefore, the value of B will now be 3 Tesla. Answer is 3. Okay. So most models, easy level, not of the level of Pathfinder. I think I have covered, but I'll cross check 1, 2, 3, 3. That is another question. 4, 4 is another question. 5, 6, 7. Some questions are still there, which I will cover in my tomorrow's class. Right. So I'm stopping here.